right, in Chapter 12, Section 1, we're going to review some three-dimensional pictures and coordinate systems. So it says, describe the sketch of the surface in R3. R3 means in 3 dimensions, represented by the equation y equals 7x. Well, y equals 7x would be a plane described by the line whose y-coordinate is 7x. Oh, just 7, actually. 7 times the x-coordinate. That is x, and then y is replaced by 7x, and z is free to be whatever it wants, where x is in dimension 1, so x is a number line, and z is also dimension 1. It's a number line going, in this it's up and down, x is left and right, and then y is 90 degrees away from x. Plane that intersects the xy plane when x at the line y equals 7x and z equals 0. Okay, and oops, I forgot to type that 7 in there. Let's see if we get this right. Yep, check mark, all check marks. Looks good. Okay, now 2 is more interesting. So plane, pretty simple. 2 is a sphere. So it says we have this sphere. The center is at the point h, k, l, and then any point on the sphere is defined by x, y, and z. So it says find an equation of a sphere with the radius r and the center at h, k, l. By definition, a sphere is the set of all points whose distance from C is r. Thus, in terms of r and p on the sphere, if and only if PC, so PC just means any line segment from the center to any point P, what must the absolute value of that distance be? Well, it's the radius. So basically this is saying the distance from the center of the sphere to a point on the outside or the surface of the sphere has to have a distance of r. Now if you square both terms, then that would give you r squared. Okay, in terms of Cartesian coordinates and radius r, the equation of the sphere is x minus, let's see here, this would be x minus the center, which is at h. They already put the y value in k, and then z is l, and that has to equal, wish that symbol would be out of there, that has to equal r raised to the second. So this is kind of a nice thing they've given us here, because that is the general formula of any sphere in 3 dimensions. It's the x-coordinate minus the center's x-coordinate, plus the y value of the point minus the center's y value, which is k, z minus the z coordinate of the point, which is l in this case for the center. And then you're squaring each of those terms. Okay, all clean and green there. Okay, for number 3, they give us a center and a point, and so the point is going to have the values x, y, and z. The center, always we assign h, k, and l, and generally we just saw this, the formula is x minus h squared plus y minus k squared plus z minus l squared equals the radius squared. Okay, so we know in this problem we have the x point is 3 minus h, which is 1. The y coordinate is 1 minus the k coordinate, which is 6, plus the z coordinate is minus 1 minus the l coordinate, which is 5. And this should all collapse to give us the radius squared, which is what we need. So this is 2 squared, negative 5 squared, negative 6 squared. 4, 25, 36, which is going to be 40 plus 25, 65 is the radius squared. Okay, now what they want us to do is write this generically, so we're going to say the general form of the sphere is x minus h, which we know is a constant. It's always going to be 1. y minus k, which is a constant, 6, always going to be that. That's where the center is forever on the sphere. z minus the L term, which is 5 squared, and now the unknown value, r squared, is 65. So that is what we have to try to type in. Let's see how hard it's going to be. So we're going to say x minus 1 quantity squared plus y minus 6 quantity squared plus z minus 5 quantity squared equals 65. Okay, 4 is twist of what we just did. So it is going to say you've got the endpoints of the diameter of the sphere. So you've got a sphere here, and you've got one point is 0, 0, 5, and you've got another point is 4, 4, 9. And what we have to do is just find the center. Well, the center is going to be exactly halfway between those 2 points. So this center is just going to have the coordinates subtracting these 2 points and dividing by 2. So this is going to be 4 minus 0 over 2. This is going to be 4 minus 0 over 2, halfway between the subtraction of these 2 points. And then we get 9 minus 5 over 2. The center is at 4 divided by 2 is 2. 4 divided by 2 is 2. 4 divided by 2 is, seriously, they did 2, 2, 2, is that right? No, so be it. So the center is at 2, 2, 2. This is HKL. So we are going to say the equation of the sphere is, but we need the radius. So before we go too far, we can find the radius by plugging in either of these 2 points. Now I'm going to plug in the one with lots of zeros because usually it's easier to compute. So we're going to use 0 minus the h value plus 0 minus the k value plus 5 minus the L value, and that has to equal r squared. So this is going to be 4 plus 3 squared, which is 9. So we're going to get 17 is the radius squared, and it's not too bad to plug in. It's going to, let me see if I can copy this. That would be handy. Control C, Control V. Oh, nice. Now all I have to do is change these numbers. This one's going to be, they're all 2. 2, 2, 2, and then the radius changed to 17. So we can do this smartly. Copy, paste the previous answer. It's the same form. And we'll be clean and green on that one. Actually, no, it said it's wrong. So let's see where we went off on this. Okay, to catch my error, I had to look at the three-dimensional picture. So if you plot this first point, 0, 0, 5, it's right here in blue. If you plot the second point, 4, 4, 9, it's this one in green. And then if you do subtract these 2 points and divide by 2, that will give you the x and y coordinate only because they started from 0. But because this one starts at 5 units up and goes to 9, you can subtract them and divide by 2, but then you have to add that number to the starting point of 5. So you have to go 2 plus 5. This number should have been 7. So all we should have to do is change this to a 7 right here. And that will change this though. So now we get 5 minus 7 is going to be 2 squared, which is another 4. And so we should have gotten 12 for the radius squared. So an easy fix, we would say x minus 7, and the radius is 12. So nice when the fix isn't terrible. And the picture can help because I had forgotten to consider where I'm starting from and adding these distances to the original starting point, which was 0, 0, 5. Okay, let's look at problem 5. Okay, for problem 5, I could try to draw this in 3 dimensions, but it's not easy to do. So instead, we're just going to use distance. We're actually going to use Pythagorean theorem in 3 dimensions. So it says find the lengths of the sides of each of the triangle PQR. So to find the distance PQ, it's just the square root of the difference of these components squared. So it's going to equal the square root of PQ, so it's going to be 8 minus 2 squared plus 0 minus 3 squared. So notice the order I'm doing here. X's with X's, Y's with Y's, Z's with Z's. Order matters, so Q then P. 3 minus negative 3 squared. And that's going to give us 6 squared, which is 36. That's going to give us positive 3 squared, which is 9. That's going to give us 3 plus 3 is 6 squared again, 36. And that's 72 plus 9, which is a square root of 81. Hey, it's a nice number, 9. So we're going to have 9 for the first one. For the second one, Q2R, same idea. R is now the first point, or the end point, so 11 minus Q8 squared plus, we're going to have minus 6 minus, I gotta make sure I go right one, Q0 squared minus 3 minus 3 squared, which is 3 squared, which is 9, minus 6 squared, which is 36, and that's going to be, was it really minus 3 minus 3? Minus 6 squared, which is 36 again. This is looking interesting. We're going to have the square root of 81 again, which is 9. This is looking to be an equilateral triangle where all sides are the same. You know what? I'm going to guess that. Let's just guess it right here. An equilateral triangle is not a right triangle. No, an isosceles triangle. Okay, we better stop then. I bet it's not a 9. They would have asked us about equilateral. So let's do this. RP. P would be 2 minus R, which is 11. Second corner P is minus 3. Minus second coordinate R is minus 6. Make sure you get these minuses right. Plus third coordinate of R is or P. Third coordinate of P is negative 3 minus the third coordinate of R, which is minus 3. Two minus 11 is negative 9. Oh yeah, this one's not going to be the same. 81. Then we have minus 3 plus 6, which would be positive 3, which is 9. Minus 3 plus 3 would be 0. Let's see, minus 3 plus 0 squared, which is 0, which is the square root of 90, which is 3 root 10. Yeah, I don't see how that's going to get us anywhere, but so is it a right triangle? It would be a right triangle if Pythagorean theorem applied, but these sides, the biggest side is 3 root 10, and if you square 9 and square 9 and add them together, you get the square root of 162, which is not going to be the same as 3 root 10. So this is not a right triangle, but it is an isosceles triangle because 2 of the sides are the same. I bet you they're going to want you to write this as 3 root 10 also. Maybe not. Let's see. Okay, so close. We kind of jumped the gun and thought, oh, 9, 9, and then the last one must be 9, but no. You got to do the math there and see that it is not a right triangle, but it is an isosceles triangle. Okay, problem 6 is not bad at all. This is a word problem. So it says, describe in words the region of R3. So again, that means in 3 dimensions. Represented by the inequality, Z must be bigger than 0 and less than 2. So when we're saying Z is a number between 0 and 2, those are actually planes. So in 3 dimensions, a letter, one variable represents the plane, and in the XYZ plane, the Z is vertical plane stacked up and down. So this would represent all the points between, actually on or between because of these equal signs. This would be the vertical planes Z equals 0. Now the Z equals 0 is the XY plane and the plane Z equal 2. So this one's not too bad, just kind of a word problem. Oh, I didn't like that. The horizontal planes. Oh, okay, yes, of course. The planes are stacked vertically, but they're horizontal planes. So they're flat pieces of paper that go up or down, but they are horizontal planes. So I did make a mistake there. Let me just correct that. Okay, problem 7. Okay, problem 7 is pretty similar, but I'm actually going to draw this one. So we've got the X, Y plane. This would be X, this would be Y, this would be Z. And this says the equation is x squared plus z squared is less than or equal to 64, or equivalently, the square root of x squared plus z squared is less than or equal to 8. So this is actually, this is going to be harder to draw than I thought. This is actually a cylinder. So on the ZX plane, boy, this is going to be tough to draw. You have a circle, and this would be 8. Over here, this would be minus 8. This would be positive 8 in the Z. This would be minus 8 in the Z. So from the center, which is the origin, 8 units in any direction will form this circle. But then, so it's a circle when you're at the ZX plane. But Y is free to be any value. So Y can actually be any value. So this becomes a cylinder that, let me not draw the other direction. It can extend in both directions. Let me just draw the one. It's hard enough to draw it. So you end up with a circular cylinder that just keeps going out like this. Okay, so it's going to be a circular cylinder. Distance from the y-axis is always 8, at most 8. And so it forms this circular cylinder, radius 8, with the y-axis. So that's what it would look like. Hopefully the picture helps visualize that one a little bit. Okay, for problem 8, it says write an inequality to describe the region between the YZ plane and the vertical plane x equal to 5. So let's draw this one again. X, Y, Z. Right-hand rule says that put your hands in the direction, right hand is in the direction of X, curl towards Y, your thumb points in the positive Z direction. So these are the positive, I've written the letters in the positive direction. Okay, so the region between the YZ plane. The YZ plane, let me write it in blue, would be this plane right here. Got to be real careful. I want to draw these lines parallel to the y-axis, and these vertical lines parallel to the z-axis. So it'd be this plane right here. And the vertical plane x equals 5. So when x equals 5, I'm going to exaggerate this. It would be 1, 2, 3, 4, 5. So here's x equal to 5. And that's, again, that's also a plane. But it's going to be parallel to the XZ plane. So this plane is out here. And so we're confining our values between those two planes. And so the only thing that's constrained is the x value. So the x value has to be constrained between 0 and 5. between the blue and the red. And that's problem 8.